All right. Give me a thumbs up if that sounds okay with the number line. Now, I know you might be frustrated. Why am I doing all this extra work? I can just count. We're going to see right now, okay? Take a look at these 2 points, points A and B. We'll get to this nasty formula here in just a second. But what I want you to do right now is, real quick, figure out what are the coordinates of A and what are the coordinates of B, right? Like we had on the number line. The coordinate is just the number it's at. But here, we're going to have 2 numbers. Because we have an X and we have a Y, right? So take a moment, figure out what points A and B are real quick by yourself. Can I get a volunteer, maybe someone who hasn't shared out yet? What are my coordinates for point A? Yeah, Colby, thank you. 5, -2. Give me a thumbs up if that's what you got for A. 5, -2. Ooh, only Aldrich and Alex and Tyler? Oh, and Ian and Aaron and Chang Z and Christian. Okay. And everybody, sorry, I saw you guys. Everybody over here. Yeah, great job. Does one of you guys have B for me? Tristan, what's B? -3, 4. Give me a thumbs up if you also got -3, 4 for B. Good. Tia did, Ian did, Kyan did. Great job. So let's go back up here, right? Really all I had to do was go from one point to the next and count all my little bumps, right? Well, let's do that here. Right? By that same logic, I can do that here. If I'm just counting from A, can I count with a straight line all the way over to B? No. Well, I did it before, right? Why can't I do it now? Think about it for a second. Just think silently to yourself. Why can't I just count with the little bumps how far A is from B? Think about it. Think about it. You guys thinking? Have you thought? You thought about it? Okay, take 60 seconds. Tell your neighbor what you thought while I walk around and listen to your thoughts. That's okay. That's all right. Don't worry. That would make more sense, right? We did A, B, we did B, C, and we're obviously doing C, D. All right. Somebody help me out because I'm very confused. Why can't I just count from A to B? I heard a lot of good ideas. Mohammed, this is kind of what you were talking about before, right? Ah, so we're dealing with 2 dimensions here. We're not just going left and right. We're going left and right, up and down. Alex, what were you going to add?
Well, I was going to say that there's no way you can count like every number on that line. It's not visual here, so how would you count it out?
Ah, I love that too. If I zoom in really, really close to this, let's see if it'll even focus that close. Maybe a little bit further. Okay. With the number line, it's nice because I see all the little notches. I can count from one notch to the next. But look at how this line splits through these boxes. That's not very even, is it? Right? And then Tyler, what were you going to add? Last one.
Oh, it's diagonal.
It's diagonal. Well, I can't count across the diagonal. Why can't I count across the diagonal?
It's where it only has 14 numbers, so then you can't count diagonal.
Say that one more time?
It's hard to count diagonal.
Yeah, it's definitely hard to count diagonal.
Not sharing the same side.
Yeah, exactly. So I love all those things. Basically, what we were saying, right, is that because we're dealing with 2 dimensions here, I can't just count diagonally, all right? So I appreciate you guys sharing those thoughts. You're absolutely right. So let's see what we can do. Okay, if I'm at point A and I want to make my way over to point B in the shortest amount of time and distance as possible, I'm just going to go in this straight line, right? but I don't know how far that straight line is. Here's how we can figure it out. This is the distance formula. Everybody has their two colors ready to go? Yeah? Okay. So we have the square root of the quantity of, in yellow, we're going to do x squared. Sorry, I don't know why I said that. Math 8, we were doing exponents. x2 minus x1. So that's the first quantity squared. Plus, in our second color, we got the quantity of y2 minus y1 squared. And that whole thing is under our square root, right? Can you guys help me out? Did you guys learn the Pythagorean theorem last year?
Yeah.
You did? Good. It may seem familiar to what we're doing here, but let's take a look. All right, we're going to do it this way first. So I got x2 minus x1. What does x2 actually mean? What am I looking for? The coordinate of the point? Well, which point? Any point? The second point. This is my second x minus my first x. Well, if I'm looking at these points here, what does it look like my second x value is? Negative 3. So I'm going to highlight that yellow, and I'm going to call that x2. That's the x coordinate of my second point. Well, that means that x1 must be what? 5. The x coordinate of my first point. What do you think y2 represents then? 4, which is my what? My second y coordinate. So my second point's y. So what's my first point's y? Negative 2. Anybody here do jigsaw puzzles for fun on their free time? Leonie, you do jigsaw puzzles for fun? Yeah? Anybody else? No? Have you guys ever done a puzzle before? Oh, there we go. Okay, maybe I should have asked that the first time. Who can tell me what's the most amount of pieces they've ever done for a puzzle? Yeah, Alex? 1,000? Okay. Liana?
Like 2,000.
Oh, wow. Okay. Aaron, did you have your hand up? 1,000? That's still a lot. What if I gave you guys... Yeah, Tristan? 4? Oh, look at that. So you guys are used to doing like 1,000, maybe 500, 100 piece puzzles, right? What if I gave you a 4-piece puzzle? How long do you think that would take you to finish? Like a second, right? 2 seconds. 2 months? Yeah, well, maybe. So let's come back together. We want to imagine this formula as a 4-piece puzzle, okay? Here's 1 piece, 2 piece, 3 piece, 4 piece. So these are the 4 numbers that I'm going to plug in those specific pieces spots, right? If I had a horizontal puzzle that looked like this, right? Okay, there's a 4-piece puzzle. And if this puzzle or this piece is x2, this one's x1, this one's y2, this one's y1, should be pretty straightforward in putting that together, right? Give me a thumbs up if you agree. That'd be pretty easy. Good. So if you think that's going to be easy, this equation is going to be just as easy, this formula. Here's what we're going to do. We're going to set it up. And this should actually say equals D. Go ahead and add that in. I forgot about that. So D, the distance, is equal to a big old square root all right. I'm going to set up my little parentheses and exponents without the numbers or the variables. And I'm going to put my 4 pieces where they go, right? What's this first piece going to be here based on our formula? Christian.
Negative 3 minus 5.
Negative 3 is my first one. I'm going to do it in red to keep it consistent. Negative 3 minus 5. right? x2 minus x1. Look at that. We're halfway done with the puzzle already. That took like 5 seconds, right? And those are my x's. I'm going to highlight them in yellow to train my brain to see that we start out and the yellows are broken up. But when we plug them in, they come back together, right? I know. It's very sweet. What's my third piece going to be? Yeah, Alex?
4 minus -2.
Perfect. Those are my last two pieces. 4 minus -2. And just like those yellow points, now my pink, or those yellow numbers, my pink numbers are together in the same quantity. So we've got them all mismatched. We bring them together when we plug them in. Give me a thumbs up if you visually see how those two are different. Yeah, Kyan does. Tristan and Jessica do. Chloe does. Aldrich. Good. So we're not going to highlight forever, but hopefully that kind of helps see things. All right, let's solve this out. This should be easy, hopefully. What's -3 minus 5? -8. I'm going to set this up. Still got D, still got the square root. This is now -8 squared. 4 minus -2. What happens when I have two minuses next to each other again? Make a big old plus. What is 4 plus 2? Nice. +6. So this is what we get. Yeah, Andrew.
Would it be like from B to A, what part of the point where they intersect? Would you do like the Pythagorean theorem from that?
Ah, yes, we definitely can. We're going to connect that at another, maybe tomorrow or so. But if you see how this is similar, that's a good, you're definitely ahead of the curve, okay? Do you guys see how this is kind of similar to the Pythagorean theorem? Anyone else share Andrew's sentiment? No? Good. That's great. We'll see it later. Don't worry. So I got I got -8 squared. What is -8 squared? 64. I'm glad nobody said 16. What is 6 squared? 36. Interesting. Take a look back, right? When we ended up with a negative distance and we took the absolute value, what happened to that negative? It became positive. Here, even though I had a negative distance, what did I do to it? I squared it. What does squaring a negative always do? Makes it positive. Oh, look at that. It all connects. Not last but not least. Second to last, but second to not least, what is 64 plus 36? 100 is what I heard somebody say. Or 100. Well, what's the square root of 100? 10. 10 what?
10
Units. Good. Not centimeters. If I don't see what the units are, what should my units be? Units. So check this out. The distance, the direct distance from A to B is 10 units long. Now, it's not like a number line. I can't just count all my little bumps and get to 10 because it's a little bit off. But it is 10 units, okay? And this is a good one, good numbers. If you're starting to see the Pythagorean theorem, that's great. Quick show of thumbs, up, down, sideways. How are we feeling? Thumbs up. This makes a lot of sense. Seems doable on my part. Thumbs sideways makes a little bit of sense. Might need some help getting started. Thumbs down. We shouldn't. Hopefully it doesn't make no sense. But okay, good. I know you guys are tired. It's been a long week. We're gonna pick our classes tomorrow, which should be fun. Hopefully. So we're gonna finish strong. Yeah. Let's